How many of you build LLM workflows every day? A few of you. Okay, we're the lucky ones. Uh, the challenge with LLM workflows is that LLMs like to hallucinate. They like to confidently say wrong information. They like to arbitrarily change keys and values when you're saying, "Hey, I want these keys and values." So it's a real challenge to get them to behave consistently. Um, of course, that's one challenge, but another challenge is cost. If you use Claude Opus 4.1, it's $15 per 1 million tokens, or I don't know what it is in euros, but it's very expensive and it's also very slow. And then if you look at the really cheap end, you have Claude 3.5 Haiku, which is 80 cents per 1 million tokens and 3 lightnings fast. Now I had an LLM make this chart, so hopefully it didn't hallucinate any of the figures. But just coarse grain, we could say that it's kind of generally in the ballpark. Um, then you have GPT-4, which is like a $5 amount. Then you have Gemini Flash. They're pretty cheap, but kind of challenging at times. Then you have Gemini 2.5 Pro, which is pretty good for coding, but in terms of it being good on the API side, I've had some bad luck with it. Gemini Flash, it's very cheap and probably the fastest of all of these models. Now it kind of depends. Sometimes you might want something that is just kind of quick, and you might have um, a couple of different models that are doing the work. And then you might have a third model that acts as the judge that judges the work of the two other models. And then the judge can decide which of the values are the most correct. And there's a lot of literature about what are the optimal approaches for LLM workflows, but that's one model that seems to work pretty good. Another is to just have a chain of LLM calls or API calls. And Anthropic actually wrote a really nice article about building effective agents. And they basically say in this article that agents are getting a lot of excitement, but you can really get a lot of power out of LLMs if you just build basic workflows. Uh, they call this the prompt chaining workflow. So on the far left, you have your inputs, then you have the LLM call one, some gate here. If it passes, then it keeps going through the workflow. LLM call two, three, and then out. Um, the input might be like a PDF document or image. Then the LLM does some things to it. It might parse some text from it. Then you have something you uh, decide what you want to do next, and if it fails, you just fail it, whatever. Uh, this is just an arbitrary workflow, so you can make it do whatever you want. But basically, the point is you can chain LLM API calls to further refine the data until it gets to a desirable output. And the first LLM API call might be just a rough capture of text or data from an image. Then you get to the second LLM API call, and that might be kind of doing a little better job. And the third one might be, okay, you are the final one. You need to get really good structured JSON output. And here's the structure you need to follow. Here's the data you need to use for that. Um, then you have some other models. I won't dive into these too much, but you guys can read this article on your own time. It's a pretty good one in terms of what are some good practices. The agentic stuff, that's still pretty new and it's pretty challenging. The agents can I've tried it and it goes down a pretty deep rabbit hole sometimes. Uh, you might have some task and then before you know it, you're researching about Burger King. Uh, and I'm like, why are we talking about Burger King? Has nothing to do with this task. But it would just do some Google research or something because you can use like search APIs, and then it decides it just wants to talk about Burger King. So agents are tricky. I think that most people can get the most value out of these simple workflows where you just have LLM API calls. Now, as I mentioned, the challenge is how do you balance cost versus speed? And then there's another one, which is reliability. And I'm going to show you a chart where um, it's kind of evident that one of the model providers is not so reliable. Um, and that's really important because when you're making production systems, you need a model that doesn't go down all the time, and you need a model that has pretty reliable outputs. It doesn't make you handle a bunch of random edge cases. So I made this model kitchen, and I'm going to break the code later on. I don't want to break it now. I want to show you a working version of it first before we try to vibe our way into a deep rabbit hole. But basically, I made this dashboard, and the benefit of having like a dashboard is you can load previous runs and see what you've done before. And you could try to revisit like different parameters you tried, different images you tried, and so on. So this one is a run. Well, I'm going to go to a different one. I'm going to go right into, I'm going to try to pull up the one that did what it didn't want it to do. Okay. So here you have the model rankings by composite score. At the top, you have Gemini 2.5 Pro. It got 2.5. Now, why could that be? It could be that the model just totally failed to do any useful output. One challenge I've had with Gemini is sometimes it'll just randomly send you repeat text as a API response. Sometimes it will send you just blank spaces, like thousands of them. It'll send you kind of what you want, followed by thousands of blank spaces. And so I found that Gemini on the API side is pretty challenging to work with. You have to handle those edge cases. And at some point, I just gave up on Gemini in terms of API calls. Gemini is good for cursor, but not so good for me when I'm trying to build something that actually works. Um, although if it is successful, then it's great. But there are those edge cases that are really annoying. Then you have Gemini 2.5 Flash. Um, it's the lowest performer here. Then you have OpenAI's GPT-4o. Then you have Claude 3.5 Haiku by Anthropic. It got an 86 composite score. We'll go to what composite score means soon. Then you have the Google Gemini 2.5 Flashlight. You got an 87. And then you got Claude Sonnet 4 here at the bottom with 90. Now, um, I want to show you this one as well. So this is a performance heat map of all the different models working on different images. So on the y-axis, you have the models, and then on the x-axis, you have the image names. So this is a sales receipt. The naming is kind of hard to read, but it's a sales receipt. This is a bank statement. This is another sales receipt. This is a travel document. No, I just took an airplane of a actually a food menu in an airplane. And then we have a Virka Turistus, which is like a Finnish church record that shows your heritage if you have heritage in Finland. Then you have a shopping something. I'll show you those images soon, but you can see that Gemini 2.5 Flash did okay on everything, and then for some reason it just kind of randomly failed on the Virka Turistus. It maybe got lazy or it sent me a bunch of space characters, and that's why I don't work with Gemini on the API side. Then you got Gemini 2.5 Pro, which just totally bombed. I don't know what happened. Maybe my API call was bad. Maybe it wasn't updated for the 2.5 Pro API because they changed it, and I can't have a consistent API call to it. But that's why I don't use Gemini in my code. I just use it for cursor sometimes. Um, but you can see these other models are doing great for these same images. Then we have the radar chart. Yes.
What are you trying to score it? Like you given a uh like you're inputting a picture and then how is the scoring be?
Oh, yes. Let me show you the pictures. Do, do, do. So this is the random picture of a today's menu on an airplane ride I took one day. Here is the bank statement. I made a demo one. It's totally fake. You can see like the person's bank account number, and this happens to deal with when someone died, and this was their bank balance after they died. This is just some random comic strip. Cool. It says, "Kung ikawa'y siram ni paliagay pansinali's extiputo kilo ominoid spaghetti pasta erika kaora yudait. Este paperito matipure nasempia." So it says, "Love, I miss you so much. I miss you," something like that. Also, we're missing 1 kilo of apples, one package of pasta, vinegar, oats, and WC paper, tomato puree, and see you soon. So it's just a snapshot from a comic. Then we have my sales receipt from Orheilu Hallittölle that we have, which is a gym. This is a viable business use case sometimes. Sometimes you might want to scan all your customer receipts, say if you're a restaurant or something. Here's another S Market sales receipt, and you can notice it's crumpled. And so we're going to see if the LLMs are actually able to pull data or text from an image that's kind of unreliable. And then this is just kind of some random chart I found online. I was curious whether they could actually parse that. I was buying a VR headset one day, so I wanted to compare them. So I took a snapshot of ChatGPT's recommendation table, and we send that over to the models. I actually ended up with the Meta Quest 3, and I got really dizzy after I tried it. So it's been a while since I tried it. Then here's a project I'm working on for targeting mosquitoes. And I wanted to see how it could pull the weird positions of all the numbers in text. Um, that's for another talk, another day. But I'm basically trying to zap them with a laser. You can see the You can see the red bounding boxes where I trained a model to detect mosquitoes in different positions when they're sitting, when they're flying. And then the green things, circles, are where I've targeted the thorax, and that's where I want to aim the laser. Um, and then the blue thing is where it's the moment of truth. So it's just showing where I put it on the mosquito when I was annotating the data. And here is the Virgo Toristus. I had a little startup, but I was trying to automate perukirjas, which is a very, very difficult legal process in Finland. And I actually got the model working really nicely with parsing these documents. And these documents can be, uh, 5 pages, and then you might have 30 of them. And so you got to get the family tree perfectly. And I could tell you that it is possible with LLMs to get the family tree perfectly from all these church records in Finland. Um, And I found that OCR actually works really nicely with these, but I found that OCR does not work well with engineering PDFs, because engineering PDFs are full of random characters and symbols that doesn't really translate easily. Like you might have what was it, the tilde, and then minus sign, and then you might have some other squiggly symbols, and then um, I don't know why, but it was really hard to get OCR to work with that. But OCR is great for documents like this. And the reason I mentioned OCR is because you might want to feed the OCR text in the same LLM API call. So that way the LLM has an image and the OCR text to refer to when it's trying to come up with the actual like truth. And it can kind of compare it. Um, although, yes,
So what does a score of 100 mean, or 90, or 80 in practice?
for composite score.
Yeah.
Uh,
Even.
oh, yes, let me go into that. Uh, but that's done. So I have a README talking about metrics. So the composite score, and I'm trusting the LLM is being correct about this. Uh, it's a weighted average of 5 key metrics, content accuracy being 20% of the weight, how well the model captures the actual information, fuzzy match, which is 15%, how similar the extracted text is to the ground truth, semantic similarity, 25%, how well the meaning is preserved, and the structural integrity is 15%, how well formatting and layout are maintained. Like, for example, in a sales receipt, you might care about alignment, so then it's human readable. And then LLM judge score, 25%, which is an AI's assessment of overall quality. So I thought this would be a fun way to combine them all. And maybe my favorite is the LLM judge score because I have an LLM tell me how good another LLM did in terms of parsing text from the image. And I was pleasantly surprised. But it does require some prompt engineering because LLM can care about things that maybe it shouldn't care about. Um, it might care too much, for example, about spacing. Maybe for your use case, you don't care about spacing.
Mm. So the first items before the LLM judge score, those are your own subjective scores, or how did you get the number?
Uh, I just had the LLM choose them, choose the weights. I say, hey, choose.
On the weights, how did you decide whether it's 50% or 20%? What's the contact accuracy like? How did you decide contact accuracy for GPT-4 OS for a certain task? How did you get that number?
Oh, content accuracy. Let me see where.
Like not specific kind of content accuracy, but like or fuzzy match. How did you get the fuzzy match for?
Fuzzy match. Okay, well, let's see where we define that.
Is there like a ground truth that it's computing against? Yeah.
Oh, okay. Yeah, let's see. Yeah, there's a ground truth. Oops. I meant to show you the ground truth documents as well. So if I go and the ground truth is really tricky um because some models are biased towards certain approaches. Like I found that Chat GPT or the GPT 4.0 model likes to format tables with beautiful little bar symbols and dashes. And so they're biased in favor of that. So you have to be careful because if your ground truth includes all that, then it will make the OpenAI model look really good. But really, that shouldn't matter as much. But here's the food menu. Here's the bank account. I've just kind of arbitrarily added some spacing for what I saw was the spacing. I had an LLM parse it, and then I just put the spacing a little bit better. And then I adjusted the alignment, like soldos the balance. So I made sure this S is aligned with the one and so on and so on. Um, in actuality, in the image, there was more like that kind of a space, but I kind of know that the models are just going to do that. Um, like look how much space is in here. So it's a little tricky to decide like what is the ground truth. Um, but I guess you can kind of generalize and kind of assume, okay, I think the models are all generally going to kind of just do like this next line thing, and they're not going to do like extra spaces like in the image. So it's kind of a fair assumption that we can. And then here's that little comic. And then here's the sales receipt from my gym. And notice how these are right aligned. If we look at how the models behave, you might notice that the text is going to be like left aligned. And so they might get a lower score on structural integrity. Here's another receipt. Then we got the enterprise LLM API market share by usage. This is that weird chart. I didn't spend much time on this, and this might not even be worth testing much, but we were just looking for like raw text extraction that's roughly in the ballpark of where it would appear if you were just to do like OCR. And then here's the recommendation table for VR headsets. Again, the spacing is kind of weird compared to the image, which was this guy here. Um, and then you have the target collage. This was the mosquito detection image. And notice how I didn't put all in spacing. That would be too much work. So I just told Claude Opus to parse the image and create me all of the text. And one thing I noticed is the models like to invent their own characters. I had to tell it, I want the box symbol because that's what was in the image. And it kept on putting like abbreviations for what it thought it was, which it was correct. It was the target and 1, 2, 3, 4, 5, 6, 7. So there's like bounding box or whatever, and then 6 is like the targets or something else. They're kind of squished on top of each other. And then you got the verticatoristus, this one. I just again tried to preserve some spacing. So this was my ground truth. Now, in a real case, I think in most business cases, you're probably not going to care about this kind of nice spacing. You're just going to care about the accuracy of the data. And you just want the LLM to pull the data accurately and create a reliable output. This is just for human reading. Humans care about this kind of formatting. Now, I accidentally made a change here, so I'm going to cancel that. Now, if I go back to my dashboard, um, we got our radar chart. And it seemed like the models generally did pretty okay with this radar chart. Um, Worst performer in this case, I think, was the yellow one, which is Gemini Flash. Yeah, you can see it blinking in the middle there. Um, this just shows you across all the dimensions which one's doing the best, and the one that fills up the radar the most is the one that's doing the best. But you can see that they're all generally pretty good in terms of like the overall area. There's no one that is completely deviating except for the Gemini Flash one, which skips some data. Um, then we have our speed versus accuracy scatter plot. And in the upper right quadrant, we have fast and accurate. And you can see that Gemini 2.5 Flash Lite did really good on this image, on the shopping image, 99%. So they probably trained a lot of data for that shopping data. Receipt, it did a good job. Good job, good job. And then again, flashlight, and we could filter these. Um, you can kind of see them clustering over here where images per second is 0.04. That's not a good unit, but um, they're all kind of above 80% accuracy or composite score, I would say. And then the worst model was the Gemini 2.5 Pro because it just totally bombed with the API calls for some reason and probably gave me gibberish. It would be interesting to compare it with another dimension, which is cost. You might care about cost if you have thousands or millions of records going through your system. And then these are the OCR experiments. I got this working at first, but then Dash Plotly was having some problems, and LLMs are not the best at Dash Plotly. There's typically duplicate callback issues, and then I don't know. I just had a lot of trouble with getting the OCR experiment working. But I would say in my workplace, I was able to do a good comparison on a text basis where it turned out that OCR didn't really improve the results. And in fact, it was a little bit worse because with engineering drawings, which I'm parsing, it would pull a lot of characters and misclassify the characters. And so I'd get like weird OCR outputs and it'd just be some random language characters because it can't understand engineering drawings. Um, So I would say that OCR in terms of value depends on the use case. For like I said, the vehicle is the church record where it's just simple text works really nice. For documents like this testamenty works great. I proved that many times in my little previous project. It can read all this. And the Finnish OCR library for Tesseract works really, really well if you're doing Finnish language. Same with bank statements, does a great job. And yeah. And then we get down to the judge analysis. So this is where the LLM actually comments on how it performs. So we were on the 36 evaluation, so I'm going to go to that. And so now I can see for those 36 evaluations, what did the judge think? So I have all the models here listed. And if I want to see Claude Sonnet 4, I can see the image and I can see I have my sales receipt. It's that kind of crumpled up one because I just crumpled it, put it in my pocket. And then the judge said you get 78.5 out of 100. And the model I used is Sonnet 4. It's a little more advanced than the haiku. It can reason a little bit more. And so the ground truth is on the left. So we have our sales receipt with the nice, beautiful formatting. And then, can you see that okay? I can make that bigger. And then that extracted text on the right, you will notice that the model, and in this case, the model that processed it was Sonnet 4. Wait, it's judging itself. I did hide it from itself, so it doesn't know that it's evaluating itself as a model. So I think models sometimes want to, they're biased. Oh, it's my friend. It did really good. So the extracted text on the left, on the right, you'll see that it didn't preserve spacing. And I think if I were to do this again, I would remove the structure a little bit in terms of weighting, because really I don't care about structure. I care that we got the right business name, that we got the right corporate ID, and so on. So I don't want the LLM wasting cognitive load on thinking about spacing.
Did the prompt ask to preserve space?
Yes, I will show you the prompt actually. Where did I put it? Prompt. Where's my prompt file? Getting closer. Thought I called it prompt. Collapse. Source. Let's ask cursor. Where is my prompt? I'll help you find your prompt and your messy code base.
This is our life view.
Okay, here's our judge prompt. So, oh, and it wants to vomit a bunch of other stuff on the screen.
Oh, it's an API prompt here. It was not the judge. Right?
Yeah. Yeah, I need to find that. Okay, prompt utils, great. Where's the... I think it's this one. Extract all text from this image with maximum accuracy. Let me change my view to be word wrapped. Extract all text from this image with maximum accuracy and completeness. Your extraction will be evaluated based on 6 critical criteria. And I changed this last minute because I realized that if the judge is evaluating them on something, to be fair to all the models, I should tell them what they're being judged on. So that way they all have a fair shot. So accuracy, match ground truth, content exactly. Every word, character, and symbol must be correct. Any errors significantly impact your score. And cats die. Completeness, capture all text elements. Headers, footers, captions, watermarks, blah, 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 blah. Format, preserve spatial structure and layout. Readability, ensure coherent, readable output. Numbers, extremely critical, 100% accuracy for all numbers. Extract text exactly as it appears in the image, preserving all formatting, structure, and spatial relationships. Ensure every visible character is captured accurately. So every model will get the same exact prompt. I realized that it needed to be this after I realized that OpenAI's ChatGPT likes to create super structured table data, and it would not be a fair comparison to say which model's the best based on structure. Well, ChatGPT is biased in favor of already creating really nice structure. So now we have this nice structured output from Sonnet 4. And then we have our category scores at a high level. Numerical values, we got a 75. It's kind of a warning signal. How accurately numbers were extracted. Key terms, 65 out of 100. And this is how well important identifiers are captured. And then if we go down, we get more detail. So I'm going to go straight to numerical values. Everything else is great, but numerical kind of struggled. Most numerical values are correct, including prices 349, 147, 496, date, time, and VAT calculations. However, critical errors include company ID extracted as Y8 blah blah blah, and pay business number was as this. I wonder if the judge made an error on what the company ID is. This is what you have to double check.
Oh, that's what it is.
Yeah, the judge is correct. Yeah, this is the actual ID, and this is the hallucination. Well, kind of hallucination.
Really cool. Can you see the image again? The other is check some built in that ID.
So here we have 1837957-3, and you can see that our ground truth is correct. Is sometimes I don't know if the LLMs use OCR or what, but sometimes they get these wrong just by like one character, and it could be like a 1 is seen as a Y or as a 7, or an 8 is seen as a 3 or a B or whatever. So um that's why you have to be careful to not give your LLM too much work to do. And that's why it's also a good idea to prioritize what exact data you want to extract. Right now, we give it a big job. We said, hey, extract all characters, all text from this image, no matter what it is. And by the way, you're evaluated on this big laundry list of things, and it's going to struggle. And so one approach you can take is, what if you only care about a certain subset of this data? And maybe the subset of the data is the top part of the receipt. And so one approach is you can train a computer vision model to create a bounding box for this part of the receipt, and then send all your images through the computer vision model to extract the sub image of the image. And then you can send the sub image to the LLM model to then extract the text from, and then you're going to have much better results. And I've actually applied that approach, and it works pretty nice. But yeah, in this case, it's too big of a job for the LLM, so it's going to mess up a few things here. But if we're comparing our models and we want to see how well they perform in this kind of a situation, that's what I'm testing here. I am testing which models are good at doing a whole bunch of work with the laundry list of requirements. And it seems that Sonnet 4 did the best based on composite score. Flash got a little lazy. It's maybe trained differently to just do very simple tasks to just extract text
Can you see also the output of those files?
of Flash. Yeah, we can take a look. So I'm going to go down. I got to collapse some stuff because I got too much going on. Flash. There we go. So this guy has the same image, and judge score 82.5 for this. And we can see it got the company ID better. So for some reason, Flash did a better job on the critical areas. And yeah, numerical values, 95. Key terms, 85. Format and structure, not so good. But you know what? Maybe we don't care about that. So if I were doing this in a real business setting, I'd probably just delete format and structure completely, because I ultimately,
Supermat? Oh, why need super? Or what?
because like if you look at the spacing and stuff, like look up the receipt on the left. You got the centering of this text. You have this header here, but this one is here with smushed with this thing. There's no next line character, or I mean, there's not an extra space. You got way too many minus signs. This receipt is way bigger than it actually is. And invented a bunch of dashes like bar symbols here.
Are those on the image map? The barcode?
Yeah, I probably thought that I could make a barcode. So I made a barcode. So in terms of the kind of, yeah, it's going good, but that's kind of cute. LLMs can be cute. Okay, so maybe we should get points for barcodes.
Yeah.
But in that case, I might want to have like a CV trained on barcodes or something, and I don't know. So the dash. Okay, so this one did pretty good. Now let's go to the other models. See if there's any others that stand out. Oops.
The other Google one that failed.
Yeah, this one did not.
The Pro one. What about the Pro one?
Oh yeah, it was the Pro. 0 points.
So I did that.
0 characters.
Yeah.
Actually, last night I was playing with this, and in one case, it actually just gave me like the first 50 characters that were accurate, and the rest were like thousands of space characters. I've seen Gemini do that. Actually, in another code base, I had it give me like the same sentence about 500 times in a huge blob, and it just didn't do the task.
What you used to cause it?
Well, I just used Google's API.
SDK.
Yeah, their SDK. I don't know. I don't remember how exactly I did it, but I know them write the API code. So maybe I made up some API call and it just totally bombed. And it could be that maybe I just didn't call the Gemini API correctly, but I think we've also had some version issues where I found like one model version had a different way of calling the API versus the other, and I don't know. I just find Anthropic much easier for API calls. Much more reliable, although they do throw a lot of 529 errors, overloading errors. But you can handle that. And you got fallbacks and just handle that. It's much better than having random garble coming back from a model. So if I want a reliable system, I'd probably do Anthropic first, then maybe OpenAI, and then maybe Gemini last. But I've actually been using Grok lately, GROQ, the one that has a data center in Finland. And they have open source models hosted on their hardware, including Llama and a bunch of others. So GRLQ, very fast tokens per second. So far so good. GRLK, I'm not going to touch that one. I don't like the person behind it. They've gone crazy. Let's see. Oh, there's a little bug. We got double grouping. Did I even show you the right stuff? It's a bug. Well, that's okay. And then here's another topic, which I think at the last minute last night, I was thinking this is kind of an important topic because, a lot of times we're making software for business people and they care about this kind of stuff. They want to see the ROI of what we're doing. And so this calculator doesn't quite work, but if I were to make it work, I would show an annual salary, the overhead in terms of taxes and office stuff, and then I would call this process like invoice processing for an accounting company, and then how many invoices or whatever per week they do, like 10. Then how long it takes them, how much it is automated by, and so on and so on. And then I added this little reading speed analysis because I thought, sometimes people think that LLMs are kind of slow, but that's if you're doing them sequentially. If you do them concurrently, you have like 5 LLM API calls at a time. Now you're 5 times faster than the LLM sequentially is. And so when you get parallelization going, you can really outperform a human in these tasks. So here, if we analyze 36 images, on average, we get a 7.2x speed up. We save 107 minutes, which is almost 2 hours. And there's a little bug there. Or maybe it's the truth. I don't know. Then we got the model performance. So you can see average efficiency by model. So I'm hoping that this is correct. Okay, Haiku is pretty fast. For some reason, Google Pro is faster. Flashlight's pretty fast. The slowest is the Sonnet 4 for some reason. There might be a bug somewhere here. Because I made this really quick last night. performance visualizations, human versus LLM. So this might be kind of boring for all of us that just want to code and make cool things, but when it comes time for budgets and whether a client's going to renew our contract or not, this is the stuff that gets the people approving budgets excited.
Apparently, if you tell this person it's gonna be 95% accurate, is it pressed by this that it's gonna be 5% inaccurate?
Yeah, that's a tricky scenario because yeah, that actually I don't know if you guys read the MI or heard about the MIT article that came out that said 95% of enterprises do not get positive ROI on their LLM and AI efforts. And I read some snippets that said that it's because of that 5% where it's inaccurate, where now everyone needs to human verify everything.
Yes.
But
So I think if you have a human that's making a human error, that's okay. We are humans, but if you are having a machine making a human error or 5% error, you're expecting a machine not to have an error.
yeah, the same thing with self-driving cars. If the self-driving car gets in an accident, it's a big deal. But humans, in the US, 30,000 Americans die a year of car accidents, but there's nothing in the news about it. But when one Tesla crashes, it's a big deal. We can't have self-driving cars.
So if you actually weigh in everything, it's much worse.
The Tesla cars?
Yeah, in a way.
Well, yeah.
Not really, because humans are reckless drivers. But if you count for all of that, humans would make the same type of mistakes. And the data is not that great because they kind of turn off autopilot at the end.
Yeah.
So it's
Well, Elon's mistake was overriding his engineers and saying, "We're not going to use LiDAR. We're going to use computer vision purely." That was his mistake,
that's
and that messed up his whole program. So, and that's a different topic. But, um, yeah, Elon's gone crazy. So, doesn't trust his engineers and thinks he's like smarter than them. Detailed analysis by image. Um, so you can see how long the LLM took by image. We got the bank account image. Um, this went pretty quickly for the Sonnet 4 model. Virka studies to 70 seconds. I forgot what this was. Um, this one is a receipt. This one's a receipt. So for some reason, it just varies, and it could be because of the data, like what's actually in the document. Um, but in any case, that doesn't really matter in the grand scheme of things if you can get parallelization going, where you have like 10 API calls happening at once. Of course, you're going to run into limits with your API provider. For example, with Anthropic, you have to have a certain tier before you can get those higher limits. Otherwise, you're going to start running into overloaded API like messages. Like I don't, it was 429 or 529. I forgot which error code it was, but you'll run into those real quick if you're on like the basic tier at Anthropic. How are we on time? 8:30 now, or 20:30.
yeah, we could start wrapping up.
Okay. So unfortunately, I don't have time to break my code, but I can run a benchmark just for fun, real quick. Is there any model you guys would like to see a quick comparison of? I have these choices:
I went to the Google Pro again, so it just redeems itself.
Google Pro versus maybe ChatGPT, or I mean GPT 4.0 versus Sonnet. Okay, so these are all like equivalent, and let's do a bank account. Run. So I'm just doing all three AP calls at the same time, and hopefully it'll finish shortly. It should be in under a minute.
While you wait for the models to work and one rest. So the human time that you calculated, how did you do that? Like, or did you start the timer and then
I like yeah. How long does it take to do a task that you do? Show me the human time calculations.
It's a input on the calculator itself. I think.
Yeah, let me take a look. Human, I put reading speed 250 words per minute average adult, full workflow 8 times reading time, includes extraction, typing, verification, document complexity 1 to 1.6 times based on content type, sequential processing 1 document at a time. And so there were a lot of assumptions made. Like if it's a really critical like financial document, it's gonna really slow down the human. LLMs don't care; they'll make up financial data. Okay, so let's see how this did. It should be done. So GPT-4 versus Gemini Pro. Yeah, it worked. And then Sonnet. So you could see that 4.0 kind of is not so good for bank statements. Of course, it's only one document. Pro and Sonnet were equivalent.
Can you see the heat map?
Yes.
Well,
It's all relative.
yeah.
It's all relative. So data can lie. That's actually a good score. And
No, I just wanted what wrote it down. What parts of the judging?
okay, let's look at 4. Oops, where am I? Oh. Wait, that was the composite score. We're looking at judge scores here. Judge scores are all pretty good. There's just a little composite score where it didn't do so well. I don't know where that is in terms of
Original.
maybe we could see it here. So the worst was GPT 4.0. Just slightly in structural and maybe less in semantic similarity.
It was the worst in the semantic too, but pretty good still.
Yeah. Overall, it's still pretty good though in terms of extraction. You can see we still got the hey, we put spacing. Great. So this is where you can run into trouble with your ground truth. Um,
It was doing better than you were expecting with the ground.
yeah, the extra space next line. So that's what's tricky. Um, and an approach like this might not be this building something like this might take you a little while, like a day or 2 or 3. In some cases, if you're just doing broad stroke assessments of different models, you might just have an LLM create different tests for you. Um, but I might try this in my workplace and see if it's useful or not. Um, I was pleasantly surprised that Haiku 3.5 is actually a pretty good model for extracting text from images. It's 50% faster than a lot of the other models. It's much cheaper than a lot of the other models, and it's like within the margin of error with the other models in parsing text, like from receipts. So Haiku 3.5, one of my favorites. Llama is actually pretty good. The 70 billion parameter model is pretty good by Grok. Well, hosted on Grok. Um, yeah, I wouldn't bother with Opus for parsing. That's very expensive. Any other questions? I thought I'd have time to break my code, but I guess not.
You know that the mosquito thing is already a commercial product.
Yes, and that's what gave me the idea. The one in China, the Chinese product with the little laser system.
Yeah.
Yeah, that's what gave me the idea. I was like, oh, that might be fun to build something like that. And they actually, it's interesting because they have like the little mirror system, so it's extremely fast moving the laser. So it's not like a servo motor or anything moving it. It's a mirror system. So I think I read it, and it was like 20 millisecond response. So like, like really, really fast in terms of targeting. Cool. Well, that's all I had for you guys today. Hopefully, something was useful. I guess one thing is if you're doing this extraction work, definitely give computer vision a try. If you're extracting from PDF documents, train a computer vision model to extract the particular tables or stuff that you want, and then do your extraction. Don't just extract the whole document. The reason why you want computer vision is you want a bounding box around the subset of the larger image, so then you can feed that smaller image and get much more accurate extraction. And you can always just take an open source model like YOLO 12n or something, and then do a transfer learning for it, and then just provide your training data, annotate your data, and then just do the transfer learning. And now you have a nice model that can now detect really reliably your tables or whatever you're trying to extract from a larger document. I've used it, and it works really, really good. So, little quick tip if you're trying to do PDF extraction, which is everyone's favorite thing in LLM world. I do that all day long, which is a lot of work. It's really tricky.
Okay, cool.
Thank you.
Thank you. Thank you.